Okay, this is 12.4 solutions. When we're looking at number one, we're looking at a situation where you have a secant and a tangent. And this is my secant line coming across here, and this is my tangent line coming across here. And in order for me to find that angle, x is equal to 1/2 my big minus my little. And this is my big, this is my little. So I got 160 minus 68. And that'll give me a 92. And dividing it by 2 is going to be 46 degrees. So x is 46. Okay. Same idea going on number 2. I've got a big minus a little. So I'm looking at my value of x is going to equal 1/2 of the difference of my big minus my little. And I've got 1/2 of 130 minus 30, so this is going to be 50. I've got two things going here in problem 3. I've got a big minus little relationship, and I've got to find that because I want to find this arc and this arc, so I can add up to 360. So then finding this arc will let me find y, and using the big minus little will help me find this arc. So that's our plan. So again, 50 in this case is equal to 1/2 my big minus little. So 1/2 of 160 minus x is equal to 50. So I multiply by 2, and I got 100 is equal to 160 minus x. Negative 60 is equal to negative x, so x is equal to 60. So I've got a 60-degree arc inside there. So I'm going to minimize this a little bit. Regroup. So we got that going on. And so I know this is 60 degrees. 60 degrees. And now I've got 160 plus 60 is equal to 220. And I've got 360 total for my circle minus 220 gives me 140. And what's that 140 do for me? This is 140 degrees. And y is equal to half of the arc it intercepts. So 140 divided by 2 is 70. So my value for y is 70. My value for x was 60. Now going on to number 4. Okay, there's a couple ways I can do number 4. So I've got this here. This is 240 degrees because that's 360 minus 120. Okay, and now I got big minus little again. 240 minus 120 divided by 2 is equal to my x. So this is going to be 60 degrees. Now there's another way I can look at this problem. Okay, the other way I can look at this problem is this way. If I take my centers and realize that that's that those tangents are going to meet at 90 degrees. And now this is a four-sided figure, and this arc, although it's 120, it's also the same as the central angle, 120. So now I'm looking for a value of x that'll add with 120 to be 180. So this would be equal to 180, where x is equal to 60. So in this case, because I have two tangents coming in contact with my circle, I have those two choices of being able to solve it. So in this next problem, in 5, I have two setups, and if I'm paying attention, I've got this is 180, okay, and since this is a center, and that's because this is a diameter, so the left side's 180, this side's 180, but I know 60 and 70 of it, that's 130, so this means that's 50 left because that's 180 minus 130, and 130 is 60 plus 70. So now, in order for me to get x is equal to 50 plus 180 divided by 2, which equals 115 degrees. For me to get my y on, that's big minus little. And if I'm looking at the big minus little, we'll take red. I've got this big arc, okay, that my angle intercepts. This angle's intercepting the largest arc, 180, and also y. okay, and it's also intercepting y. So now I've got 53 degrees is equal to half my big 180 minus my y, my small, okay, my little guy. So now I'm multiplying like 106 equal 180 minus y, and I subtract 180, I get negative 74, and 74 is equal to y. Now looking at this next one, it looks really difficult. But if I recall that I'm looking at central angle, and that's going to be 5 of them, 360 divided by 5 is 72. Not only is that the central angle, but it's also my arc for x, which is 72. But you got to keep in mind, this is an arc of 72 degrees going along here that angle y is intercepting. So half of 72 is equal to my angle y, which is 36. So angle y is 36 and x is 72 degrees. In 7, 8, and 9, we're looking for lengths and not angle values. We're looking for lengths and not angle values. So I'm just going to group this and get it out of the way here. Okay. So I'm looking at this idea of chord. You know, maybe perhaps your instructor just calls it the 2 chord, and I just talk about chord. So I got 20 times 6 is equal to 8 times x. So here I'm going to divide by 8 on both sides. So I've got 120 divided by 8 is equal to my x value. And after putting in my calculator, 120 divided by 8, I get 15 is equal to x. Now on this next one, same idea. I'm looking for x, and I got 15 times 20, because it's 2 parts of a chord, it's a chord-chord relationship, is equal to 26 times x. So I've got 300 is equal to 26 times x, and I divide by 26. And I'm going to get my x is 11.5. The difference between 8 and 9 is pretty obvious. In 7 and 8, I was using chord-chord relationship. In 9, I'm doing the outside times the entire length or the whole length. So I'm going to take 11 times 31. And that is going to equal 13 times 13 plus c. Okay, and that's my relationship I'm working with. Well, I'm going to take that 11 times 31 and then divide by 13. Well, let's do 11 times 31. That's 341. I got 13 plus c. I'm going to divide 341 by 13. And I got 26.23. I got a bunch of stuff in my calculator right now. Equal 13 plus c. I'm going to subtract 13 from 26 and get my value of 13.2, because I'm supposed to round to the 10th, for my value of c. Okay. Going on here. I've got problem 10, same idea. I've got 2 secants, but again, you got to keep in mind, it's the outside value, x, times the entire length. In this case, they're telling me the entire length, 6, is equal to the outside value, 3, times the entire length, 7. So now I've got 6x is equal to 21, and x is equal to 21 divided by 6. It's going to give me 3.5. So x is 3.5. In 11, I have 2 things going on. I have this one and this one. So I'm going to go, hey, well, you know, y squared, that's the outside times the entire length with a tangent. Tangent is y squared, and a secant is 7 times 22. So now I got 7 times 22, and 22 is 15 plus 7. 7 times 22 is going to get us 154. So now the square root of 154 is going to give us 12.4. Now, y is 12.4. I'm not going to use that. Actually, let's make that blue so we know that that came from the blues. I'm going to use this here. So now I've got my outside for my x. Outside is 7 times 22 is equal to 5 times 5 plus x. So this is 154 is equal to 25 plus 5x. If I subtract 25 from 154, I'll get 129. If I divide by 5, I'll get 25.8 is equal to x. So my x value is 25.8. Now in 12, I'm looking at another combo, okay? In my first one, I'm going to find this value of x because I need that x to find the answer in the chord-chord relationship. So again, it looks really complicated, but if I can just focus on what I'm working with, I got a secant and a tangent, and this tangent squared, the outside times the entire length, same value, that's why it's squared, is equal to 7 times 7 plus 5 plus x, okay, because that's that whole length of that secant. Now that's 12, and I've got 121 equals 7 times 12 plus x. And now I've got 121 is equal to 94, or 84, plus 7x. 121 minus 84 is equal to 37. So I got 37 equals 7x, and I divide by 7. And I'll get my 5.3 is equal to x when I'm done there. So that's my x value. Now I'm going to use that value of x to find my y, but I'm going to use 37/7 because I want to use that whole value of x. I rounded to get to the 5.3, and it's not so bad. All I'm going to do is use this chord-chord relationship now. Okay, so now I've got 5 times 37/7 is equal to 9y. So 5 times 37 divided by 7, and then I'm going to divide again by my 9, and I should get 2.9, and I get to round this. 2.9 is equal to y. So my y is 2.9, and my x is 5.3 in that problem. And we'll shrink it down, be able to get to our next one. Now here, in 13, 14, 15, I'm doing combinations of things. I'm asked to find the diameter. And this is a secant, this is a tangent, so I've got my tangent squared because the outside times the entire length, and I've got my secant, which is the outside times the entire length, and I'm just to multiply away, so I get 625 is equal to 225 plus 15d. And I got 625 minus 225, which is 400. And I'm going to divide 400 by 15. And I'll get 26.7. So my diameter is equal to 26.7. Now, in this next one, I've got to recall a couple things. First of all, when I have a diameter and it's perpendicular to a chord inside the circle, it actually splits the chord into 2 equal parts. So this is 8 as well. So now I'm looking for that. So I've got 8 times 8 is equal to 6x. This is 64 is equal to 6x, and I divide by 64 divided by 6 is going to give me 10.7. So x is 10.7 if I round. So that is not my final answer, though. They asked to find my diameter. So my diameter is actually 6 plus 10.7, which is 16.7. Now on the last one, it looks really difficult But there's a couple things I'm going to do. I'm going to use the idea from 14. If I extend this across, that is a chord. And remember, this diameter going across here splits that chord into 2 equal parts because it's perpendicular. So this is 5. I got to use Pythagorean theorem to find this length. So I've got 5 squared plus whatever my x squared is equal to 13 squared. X actually ends up being 144, x squared I should say. So x is 12. So I now know x is 12, and I'm going to use the idea of chord again, or the 2 chords, where I got 5 times 5 is equal to, and I'll call this y, y times 12. So I've got 25 is equal to 12y, and I get divide by 12, and I get 0.083. 2.0833 is equal to y. Well, if I round to 2.1, and now I'm going to add to find my diameter is equal to 12 plus 2.1, which is 14.1. So I was able to find the diameter with each one of those using my other properties. Now let's get this stuff all minimized here. See if we get this out of our way. And get on to the next thing. A circle is inscribed in a quadrilateral. This has got to be 85. This has got to be. It's got to be 86. 74. Oh, that's right. Nothing else will work on that. Let's skip 16. That's not going to work for us. Let's look at 17. Pqr is inscribed in a circle. So I've got a circle. And I've got a triangle that I'm going to inscribe inside of it. So I've got a triangle inscribed in the circle. Triangle PQR is inscribed in a circle with measure of angle P. So I've got P, Q, and R. And P is 70, Q is 50, and R is 60. And they're asking me, what are the measures of arc PQ? Well, first of all, arc PQ is across from R. And remember, the inscribed angle R here, which is 60 degrees, is half the measure of the arc. So I just take 60 times 2, and I get 120. So my measure of arc PQ is equal to 120. Now let's look at QR. My measure of arc QR is going to equal 140 because that's 2 times 70. So that's 140. And then my last one here, I'm looking at arc PR. And that's across from Q. And that's going to be 2 times 50 again. And that's 100. So the measure of arc PR is equal to 100. And these are all degrees. Okay, and that's 1 through 17. Hopefully things are going well. We'll talk to you soon.